All right, class, I think what I'm going to do tonight is I'm going to have this video of me going through the loops chapter, and then we can make it kind of like a Q&A session because I know the chapter 2 test is due this week as well. And then if I start hacking up along, I'll be able to pause it, and then you won't have to deal with me, because I'm feeling much better, but I still have a bit of a cold, and the COVID was negative the other day when I tested, but it's still like in my lungs or whatever. So anyway, we'll just see how it goes. I'll let you guys know, and then you either watch this video or not. Okay, so this chapter is all about loops, and the whole purpose of a loop is to do something over and over and over again and automate a process until you want to quit. Okay, so I always use like the concept of like a shot clock, like where it's like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Does it go to -1? And it doesn't, because it's built in to repeat over and over again until, that number is 0 basically on a shot clock. Let's see here. So it looks like they're, driving the baby around the block until it stops crying, basically. So this is going to use a while loop. Where it's just going to allow you to enter numbers. So val is 0 you're going to enter 2 in, it looks like. So 0 plus 2, and the new value of sum is now 2. So you can see where sum went from 0 to 2. And that's greater than -1. So then you come back up here. Sorry, val was 2, so that's not -1, so it's going to run again. And then they enter 4. 2 plus 4 is 6. And then they enter 1, so 6 plus 1 is 7. And then they enter -1, so -1 is not greater than -1, so then you leave. It looks like it's doing the exact same thing here, only it's adding 1 to num each time. You guys can do some of these on your own. These aren't hard, but those are decent, exercises you guys can work on. Okay, so I honestly would have just started here and just gone straight to, sorry about that, and just gone to loops, while loops. And it just shows you the structure of a while loop. So looks like you got your current power is 2, user char is y. So while the user char is y, so you would usually you do a while loop when you don't necessarily know how many times you want to loop through it, through whatever you're going to loop through. In this case, as long as the user char is y, then it's going to loop through over and over again. But when that changes, when the user inputs a different input, then it will end. But you don't know how many times the user is going to enter y in there. Okay, so so then we're going to print the current power, which is 2, and then we're going to multiply the current power by 2, which makes the current power 4. And then I'll input y again right here. So, and then we'll print the current power. So that's 4, and then we'll multiply the 2 again. It'll be 8, and then they enter n, So then it's done at the end after that. So this one, like, how many times is it going to iterate? How many times is it going to run through this? Well, x is 3. Is 3 greater or equal to 1? Yes. So we'll do this, and it becomes 2. And then is 2 greater than or equal to 1? Yes. So it comes down here, 2 minus 1, and then is 1 greater than or equal to 1? Yes. So then it's going to be 3 times. Okay. So if this is going to be n, y, it would be 3 times as well. Oh, wait. As long as it's not equal to n. So the first time through, n is equal to n. So yeah, that makes sense. Sorry. Assume the user would enter A and then B and then N. So A would not equal N, B would not equal N, but N would equal N, so it would be 2 times. So sentinel values are what get you out of a while loop, or it could, like in this case, while it's not equal to Q, it will run this, but when it is equal to Q, user value is your sentinel value, and when it is equal to Q, it'll be done with this. So that's what a sentinel value is. So these are good ones too, little easy ones to practice. So while x is less than, so x less than 100, and then a semicolon. Oh, well, okay. This is how you would add. You do want to have a semicolon. See the semicolon after the while loop. So that to me is an error in this, but that's fine. I don't care. They didn't want that. But iterate while x is greater than or equal to what? 0. X is greater than or equal to 0. Okay. So while C equals G. So when you're doing equals to in this, it's like with if-else statements, you have to use double equal symbols. Oh. Until C equals. Okay. Oops, yeah, that makes sense. You can read that closer. Okay. Stepping through a while loop. Okay. I usually teach my high school kids this tables type method to organize things when you're trying to think through how this works. So right here, this is your iteration, whatever loop you're on. Then you've got a number value, and then you've got output. I actually wouldn't organize it like that. I would actually do it like this. This is just easier to do in my head. But I would do and then use like the tab button, and you might not need that much space, but use a tab button, it's nice. And then you do print num modulus 10. And then num then you can put like a line in there. And then I don't know what it says value. Num is 902. Is 902 greater than 0? Yes. So you print you know, that would equal that, and then you can kind of go through, you know, this would be what, 90, and you could do this each time, you know, 90 is greater than 0. That's how I would organize this. This is, I call this the tables method. And anyway, you could do this for just about anything you're working on to kind of slow your brain down and go through each step, especially when we start getting to loops. I personally think this is where programming gets difficult, especially when you're you know, a beginner programmer. If this is your first class, I mean, just about everything up till now kind of, you know, it's, some of it can be confusing, but the learning curve starts getting steeper when it goes to loops, because now you're kind of, you know, everything we've done, we got it kind of combined, and now we can do it over and over again, and it's just, it's kind of a complicated way of thinking in my mind. At least that's where I thought programming started to get difficult. So right here, x is not greater than 0, so it's just going to print by. Okay, you know, and this is also super important. Notice the white space tab in here. This is where, you know, Python knows that these two lines of code are inside the while loop. Okay, that's going to be hugely important. You're going to have to make sure your white spaces line up. Let me pause it. Okay, this one you got x is 5, y is 18. Is 18 greater than x? Yes. So it's going to print 18 and then do 18 minus 5. And this is where, again, this is, I would definitely be doing, you know, you got your x value, you got your y value. Is y greater than or equal to x? And if it is, what do we print? You know, y. And then we can do y equals y minus x. And again, like, you know, I've met some high school kids that can do some pretty wild loops in their head, and I just say, you know, slow it all down. Because I definitely can't do that. And so what is this going to be? 13 equals 18 minus 5. So x, the value of x never changes, so that's still going to be 5, right? But then y turns into 13, and 13 is still greater or equal to 5, so it's going to print 13. And then you've got 13 minus 5 equals 8, right? So x is still 5, becomes 8. 8 is still greater or equal to 5. So it's going to print 3. And then no, wait, what did I do wrong here? It's going to print 8. And then 8 minus 5 is 3. And then is 3 greater than or equal to 5? No. So I don't know what it's asking for. Is it just asking what the final value of y is, or what's the final output? Final output should be 8, but the final value should be 3. Let's see here. Oh, okay. So it just wanted me to write down, which I did, 18, 13, and 8. Okay. I just didn't know what they wanted me to put down. But you can see, like, you should go through these. I'm not going to do all of them, but you should go through all these in table form and write them out so that you know everything that's printing. And to be honest with you, when I talk about, controlling your code, this is how you control it. You know what's going on each step. Okay. And it's a process, so it's not something that's just instantaneous. I spent a lot of time on worksheets with students at the high school level, having them write that out and forcing them to do that. Okay. Okay. And I did a bunch of different programs, just like, I didn't do this is going to be the greatest common denominator. I didn't do this, but like I did a ton of different programs in my videos that I demonstrated, so you can see how all that works. Okay. And I'm not going to go through that one. Okay, I don't know, rand int is kind of nice. Get a random integer if you need to use that. So like right here, if I want a random integer, 0 to 2, it's going to give me a random number between 0 and 2. This is just some sort of like simple conversation that the computers or the program's going to do with you. Again, I'm not going to go through that. Let's see here. Yeah, we did a bunch of these. These are all kind of little things you can work through on your own. This is kind of important to know how to find like a minimum and maximum number in your list right here. So you've got a sentinel value where it's got to be greater than 0, right? So if you enter 0, it kicks you out. And if your current value is greater than your max value, so your max value is just your current value at first. So 2 would be your max value, right? So it would skip that. But then you would enter another one, so you enter 34. And then is 34 greater than the max value, which of 2, yes. So the new max value is 34. So then you enter another number, 12, and then you come back up here. Is 12 greater than 34? No. And enter 0 to quit, but that's your max value. You can find the minimum value doing that too, only you would do less than min value. Again, you can do that. Okay, so if you know how many times you're going to run your loop, you have to have some sort of counter variable, which is usually like an I. So you start off I as 1, and I is less than whatever your, the number of times you want to iterate. And then you run your body, and then you do I equals I plus 1. Sorry about that. I was definitely I was coughing a bunch there. All right. So this would be like a simple interest rate calculator for savings. So you would enter your years. So let's say you wanted to have 10 years of savings calculations at a certain rate. 1 is less than 10, so savings begin at year, and then Whatever year was entered. Let me see here. Okay, your initial savings is 10,000. So anyway, you'll just do, your 10,000 times 0.05, and then you would add that to the savings, right? And you would just do this, and then I would become 2. 2 is less than or equal to 10, and it would just do this over and over again. I would be 3, then 4, then 5, then 6, 7, 8, 9, 10. When it became 11, it would exit the loop. I don't know, it's right here if you want the loop to iterate 10 times, so I would be, less than or equal to 10. Okay. Again, you need a semicolon at the end of that. I don't know why they didn't do that. If I want to do 99 times. So what do they want? They just want I equals I plus 1 here. Oh, the odd ones? Okay, sorry, I didn't read that right. That makes sense. Because look at 1, and then you would add 2 to it becomes 3. Add 2 to it becomes 5, okay? Multiples of 5 from 0 to 1,000. When you see that word inclusive, it includes the end one. So the odd one. So this would be what I equals I minus 2. Because it would be 209, 207. Okay. And these are all good little simple programs. Like I said, I've got a bunch of the other larger type programs in my loops videos. So we're going to get into, these are the for each loops, a little bit different. So this is saying for a variable in a container. So the container is typically, you can see it right here, it typically is like a list. So the variable is just whatever value you give it. So what happens is for name, you're just giving it a name, a placeholder. For name in the container, this could be list. In this case, it's going to actually just show the list. It's going to print the name, so it prints hi, Bill, Nicole, John. the name variable becomes where you're at in the list after each run. Okay. So this is a dictionary right here. So for C in channels, so C becomes this right here, right? Would be MTV, CNN, Fox, NBC, CBS. But then when you put, the channel C, that's actually asking for the value, which is going to be 35, 28, 11, 4, and then 12. Oh. Okay, so you can do this with strings too. So for character, that's just your placeholder in this string. And then what are we going to do? We're going to put an underscore in between each one. So character is a T, and then you add that underscore, and you add that into my string. Then you go back up again, and then it becomes A plus the underscore, right? We add that to the T and the underscore, so on and so forth. Again, you could just call it X. It doesn't really matter. No, they want you to call it my pet. Okay. For variable call number in, and what, 911. So look at this. For day is your variable in the daily revenues. So day will be this the first time through, and then it will be this the second time through, and then it will be that third all the way to here, and it'll add them all up. This is all kind of the same stuff. So total would be num. This would be your number variable that goes through each of these if we're adding up the total number of kids. So we're going to add up the number of negatives. So it'd be a negative here. So it'd be 1, 2, 3 negatives. Oh. Use the reversed function. Find the scores in order from highest to lowest. Is it dot reversed? Is that reverse scores? Okay, yeah. So what that does is it takes the scores function, or sorry, the scores list, and it reverses it. Sorry, I didn't see what it was asking there. Range is kind of nice. You can give it a range. So for 5, it would be 0, 1, 2, 3, 4. 0 to 5 is going to be 0 to 4. 3 to 7 is going to be 3 to 6. So it's important to know that that last one, it doesn't actually hit, it goes before it. Looks like you're entering 8 for years here, and you're seeing how much it's going to make you in the first 7 years of that. There, and then here, right? Okay, and you can do these. Okay, so in older languages like in Java and C++, they had in Python they just called a for loop. In my mind, this in Python doesn't use a for loop. They use a for each loop, and the for each loop was come up with because like it says in here, it talks about out of bounds errors or infinite loop type problems that can occur with while loops. And so the for each loop basically takes care of that because it's within whatever, if you've got your list, it's going to run through every single item in that list. It's not going to have an out of bounds error or infinite loop type error. Because think about this, if we didn't add up I right here, let's say we forgot this line of code right here, that would be an infinite loop. It'd run over and over again. Where in this one, it's just I in the range of 100. It's going to run to 99. Ooh, nested loops. This is where it gets real fun. You've got loops within loops. Again, sorry I had to stop that. Alright, so this is kind of an interesting nested loop. So we've got letter A, and then letter 2 is just a question mark. Is A less than or equal to the Z? Yes. So letter 2 is going to be equal to an A. And is A less than Z? Yes. So it's going to print A and A.com, which it does right here. Okay. Then we're going to add 1 to letter 2. So letter 2 becomes B. Okay. And is B less than or equal to Z? Yes. So we print letter letter 1 is A, letter 2 is now B, so it's going to print this. Okay, so it's basically going to run through all letter 2's until it's Z, right? So it's going to go all the way to there. So you've got A through AB, AC, all the way to AZ, right? And then when this is done, we're going to add 1 to letter 1, and then letter 1 is going to be B. So is B less than Z? Yes. So then now letter 2 becomes A again. So we've got B, A, and then it'll be B, 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 C, B, Z, and then it'd be C, A, and so on and so forth, all the way to Z, Z. So think about this. How many times will the inner loop execute? Well, the outer loop's going to do a 0 and a 1, right? So it's going to execute twice. And the inner loop's going to be a 0, 1, and a 2. So the inner loop's 3 times. So then you would just do the outer loop 2 times the inner loop 3. It's going to give you 6. And this will be 0 to 5 or 0 to 4, so that's 5 times. And this will be 10 and 11, so 2. So that'll be 10 times 5 times 2 is 10. And you can kind of run through these on your own. And I go through, I think, some triangle type stuff. You know, kind of similar to this, only it looks like in some of my other videos, something like this. Okay, so how would you print that up using nested loops? So I do some of that in some of my other videos. Okay. So incremental programming, they're talking about just incrementally adding more complexity to it. You can kind of see what they're doing. Break and continue. Break will leave wherever you're at. So a break statement in a loop causes a loop to exit immediately. A break statement sometimes yield a loop that is easier to understand. I usually don't use break because I usually do it like within the, you know, well, sometimes you need it. Sometimes you can get away with not even using it with your if-else type statements, your Boolean conditions, and it will just skip over whatever you're trying to do. Alright, a continuous statement is a loop causes an immediate jump to the while or for loop header statement. So we jump back up here. I don't know, we don't do a lot with that this semester. Yeah, I've never used this while else. That's never made sense to me. Because look at it, if it's going to run everything in here, and then when it's false, it's done, why would you just not put the whatever it is you're doing below it afterwards? I don't know, that's just, yeah. Look at it, a loop may include an else clause that execute only if the loop terminates. So yeah, when the loop terminates, just do your code after anyway. I've never understood the purpose of a while else, but Yeah, like I said, I'm kind of more of an old school programmer, mainly more in Java. Um, but shoot, go for it if you want to use it. It works fine. It's just it never really made sense like this. Like, if you're going to do everything in here at the end after it, just do print all names printed at the end. Why do you need to use an else statement? It's not like it hurts anything. I just don't understand it's almost like in Python, you see what I'm saying? Like it's going to do everything in here, else it's going to do that. So why don't you just put that right here outside the for loop, and then it's going to print that. I've always tried to make things as easy as possible, and again, this isn't like it's difficult. I just don't understand, like, okay, once everything's printed, then the for loop's done, and then you just print that at the end. So it's almost like they just come up with different ways of doing things that like have already been solved, and most programmers know how to do anyway. I just, some of it I don't get. Anyway, you can go through those. Yeah, there's not like a lot here. You can go through this. This isn't, we don't do a lot with that either. Practice dice statistics. It'll be kind of fun to use. You get your random int with your rolls, and you're kind of looking at, how many times the total rolls are 6 or 7. So you can play around with that. It prints up, like a histogram of this. So that's kind of fun to do. It's a fun little program you can work on. Yeah, I think this is where it's just getting into the labs that you need to work on and complete on your own. I believe, let me make sure. Go back in. Yeah. So, I don't know. That'll be that. And like I said, I think what I'll do is I'll just present this video to you guys tonight, and then we'll do a Q&A. So this video's done.